And a couple of functions, f and g. First up, let's focus on f. It's 7 minus 2x squared, so it's a negative quadratic, and it's defined over all real numbers. State the range. So the range is your y values. Your domain is your x values. When you define a function, you technically should always define the domain, which we have here. But the range is then follows from it. Now, I personally would advise a little sketch from this. So minus x squared looks like this, and so is minus 2x squared on a slightly different scale. If you then add 7, it looks like this. It's actually in completed square form. Technically, the maximum is going to be 7. And that means we can have all values of the function that are less than or equal to 7. So you can either say y is less than or equal to 7 or f of x is less than or equal to 7. Next up, find g of f of 1.8. You can find g of f of x in terms of x and then substitute in, but it's in fact going to be just easier to just sub 1.8 into f. So 7 minus 2 times 1.8 squared, which gives 0.52. So it becomes g of 0.52. So that's my output for f of 1.8. It becomes my input into g. So 3 times 0.52 over 5 times 0.52 minus 1, which gives me 39 over 40, or 0.975. Finally, we're asked to find the inverse function of g of x. So let's do a simpler one to start with. H of x equals 2x plus 3. So we're timesing by 2 and then adding 3, which means for the inverse, we would minus 3 and then divide by 2. We do the opposite thing. It's a lot harder when you have an x at the top and at the bottom. So there's a different process for doing it. And I'm just going to demonstrate with this 2x plus 3 to give you some insight into it and convince you. So if we have y equals 2x plus 3, what we can do is make x the subject. It would be y minus 3 over 2. Now that is actually getting us from the output back to the input, and then the inverse, you would just put it back in terms of x, because we always use x as our input. And what I'm trying to say is we do exactly the same thing here. So this is C. Let y equal 3x over 5x minus 1. We want to know how we can get x from y. So I need to make x the subject of this. It's a fraction we can multiply through. So 5x minus 1 times y is equal to 3x. Multiply out the brackets, 5xy minus y equals 3x. Now get x on the same side. I'm going to add y and minus 3x. So 5xy minus 3x equals y. The reason I'm doing that is I can now factorize out the x. Remember, that's what I want in terms of y. So x 5y minus 3 equals y. X equals y over 5y minus 3. We're very nearly there, just like I went from here to here before. Our inverse function is going to be x over 5x minus 3. That is all that's required in this question, although technically I would say we should state the domain. It's going to be all real numbers, except we cannot have x equal to 3 over 5, because again, that would make it equal to 0. But for 2 marks, actually, there's quite a lot to do. It's just this expected. But technically, we should state the domain. And just for interest, the range would be all real values except a fifth, because the domain of our function is the same as the range of our inverse, and vice versa. So the range of g of x would be all real values of x except 3/5. I haven't technically shown that, but I think this ends up being a reciprocal. In fact, we could do a little bit of division. Do you know what? I'm going to sketch it. It's worth practicing these sorts of things anyway. So 3x over 5x minus 1. I'm going to divide into it. So 5x into 3x goes 3/5. Multiply back through. 5x minus 3/5, which when I minus, oh sorry, when I times it, that should have given me 3. 5x times 3/5 is 3x, 3. So when I subtract it, I'm going to get 3/5. And what I've actually just shown is that I've got 3/5 plus 3/5 times 1 over 5x minus 1. I mean, technically it's 3/5 divided by 5x minus 1, but I've just written it like this. So I can see from here that it's a fifth that's not allowed, and I'm going to get an asymptote there. And then it's like a reciprocal, except I'm stretching it slightly and I'm adding 3/5 to it. So sorry, I'm doing this quite quickly, but 3/5 is going to be there. It's going to basically look like that. Where's it going? When x is 0, it's actually going to go through 0. So there we have it. That x can't equal a fifth. There's an asymptote there. There's also an asymptote here, which is at 3/5. So the function can't ever reach that. That's why that actually became the domain of my inverse. I'm not going to get into more detail on that, but that is how you can sketch a function like this. You can do some division, and I was just trying to convince you really to start with where this comes from and why I can definitely say that the domain of it is all real numbers, because the range of the original was all real numbers except y equals 3/5. Anyway, well done with this question.